We continue our discussion on circles by covering arcs, inscribed angles, and radians. An arc is a part of the circumference of a circle. You can see in the picture that I have an arc indicated. It would start at point A and end at point C. There are, of course, other arcs in this circle. I could talk about arc AB, which would start at A and end at B. I could look at BC, starting at B and end at C. So we can talk about different arcs, but we do give points to indicate where it starts and where it stops. An arc that has a length equal to the radius forms an angle that is called a radian. It's important for you to understand that the radian is the angle that we're forming and it's not the arc. So the arc has the length of r, and the angle that it forms, that is called a radian. Remember, the circumference of a circle is 2 pi r. If I put 2 times pi in my calculator, it gives me about 6.28. So we could approximate 2 pi r as saying it's 6.28 r. What I did in the picture is we said the angle that is formed by a distance that equals to the radius is called the radian. So notice we have this 6.28 r. So I have 1, 2, 3, 4, 5, 6 of my r, and then a little bit left over. So this is showing you that the circumference outside of 2 pi r gives me 6.28 radians if I'm looking at my angles. Let's look at that a little farther. If we think about the 2 pi r as my radians that we just indicated on the inside, that I have 6.28 radians, and I make it equal to 360 degrees, I could solve for r by dividing by 2 pi. So r, I can simplify 360 over 2 is 180 over pi. Well, what does this do? It gives me a way to convert between degrees and radians. To convert from degrees to radians, we're going to multiply by pi over 180. Let's convert 60 degrees to radians. So I have 60 degrees, and I want to change that into radians. I'm going to multiply by pi over 180. I think it's helpful to put the degrees in so you can see where they're going to cancel out. The degrees from the 60 will cancel with the degrees from the 180, which will leave my answer in radians. So here I'm just taking my calculator. I'm going to take 60 times pi and then divide by 180. You're always going to get a decimal. I got 1.0, let's say 5. I had 1.047. Okay, so this went from degrees, and now this is in radians. Let's do it again. This one says 115 degrees. I take my 115. I'm going to multiply by pi over 180. I have 115 times pi divided by 180. This gives me 2.007, so I'm going to call it 2.01. Now I'm going in the opposite direction. Notice I'm giving you radians and I'm asking you to convert to degrees. So I'm going to do the opposite thing. When I went from degrees to radians, I multiplied by pi over 180. Now that I'm going from radians to degrees, I'm just going to flip it over and do 180 over pi. So the 1.5, I multiply by 180 over pi. This gives me 85.94, and now my answer is in degrees. And then the 0.33, I have 0.33 times 180 over pi. This gives me 18.91 degrees. Let's do 2 more. I have 1.57. I'm going to multiply by 180 degrees over pi. This is 89.95 degrees. And then I have 0.174. Again, I'm multiplying by 180 over pi. get 9.97 degrees. Let's talk about inscribed angles. An inscribed angle has the endpoints of the angle and the vertex of the angle on the circumference of the circle. So in our previous examples, we were looking at the center, and we will use the center to talk about the radians and to look at degrees. Now, for this example, you can see B, which is the vertex, is actually on the circumference of the center as well. So it's important that all 3 points that make up the angle are on the circumference of the circle. So let's just decide if the angle is inscribed or not inscribed. So look at my circle. I have this big circle, and then I want the angle AOB. So what do you think, inscribed or not? The answer should be not, because O is the center. It's not on the actual circle itself. How about this one? I'm looking at ACB. Is this inscribed? Hopefully you said yes, because this time C, which is the vertex, is touching the circumference. An inscribed angle has a corresponding arc that's on the opposite side of the angle. The measure of the arc is always twice the measure of the inscribed angle. For example, in this circle, I can see I have an inscribed angle ABC. When I look, it forms an arc from A to C. The measure of the arc AC will be 2 times 55, which is 110 degrees. Let's try that again. I have an inscribed angle, CBA, that is 48 degrees, and I want to find the measure of arc AC. To find AC, I'm going to do 2 times 48, which is 96 degrees. Let's find the measure of the indicated arcs. A is the center of the circle, tangent to the line at D. Given the angle EDC is 75 degrees, find the measure of the arc EC and the arc DC. So let's go through and see, what do we know, what do we need to know, and then really what is the connection. So we start with A as the center of the circle. That's good, so I know A is the middle. It's tangent to this line D. That just tells me that when the circle is touching the line, it's just touching at one point, it's touching at one point D. Here's what's important. I know EDC is 75 degrees, so I have EDC right here is 75 degrees. When I look across from it, I can see this big arc EC. I can use that to figure out the measure of the arc EC. So I take the 75, I multiply by 2, and it says 150 degrees. So let's label that as EC and put the arc on top. Okay. Then what do I have left? I want to figure out DC. So DC is this little bitty arc remaining. I know A is the center of the circle, and I can see I have a line going from one point on the circumference to another point on the circumference. So when I put this through, this is the diameter, and it's cutting the circle in half. So that tells me this half on the left would be 180 degrees, half of 360, and then the other half on the right will also be 180. Well, what do I know? I have 150 degrees already, which was EC. That says what's left, 180 minus 150, which is 30 degrees. This will be my arc DC.